All right, everybody. Hey, we're going to go ahead and get started now, I guess. I'm still waiting on a couple people, but hopefully they join us shortly. Welcome to Chem1CL. This meeting today should probably be the longest one we have by far, just because we have to cover the syllabus and also experiment 14. So in future weeks, we should only probably meet for like a half an hour or so to talk about the lab, and then I'll stick around for the rest of the hour for us to work on the problems and stuff like that. But for now, we're going to have to just jump right in and start talking about the syllabus. So I'm going to start sharing my screen here. All right, are you guys all able to see the PowerPoint? Cool. All right, so this is 1CL. Today's agenda, we're going to go over just the introduction to the course and some of the links that you guys need. Hopefully you guys have all kind of figured this out already at this point. Second, we got one more person coming. We'll go over the syllabus and then the general course expectations, including talking about future lab meetings, my expectations for your lab manuals, lab reports, and then we'll have an aside about this EliReview assignment thing, which I don't know if you guys have heard about that at all, but we'll talk about it. We'll talk about quizzes, we'll talk about the grading structure for the class, then we'll have a time for some questions just about the course overall. Then we'll launch right into experiment 14, which should take hopefully no more than 25 minutes or so. And then I'll talk about the assignment deadlines that are coming up for the next couple weeks. So first of all, I wanted to start with a Zoom poll just because I've never actually used polling on this Zoom before, so I want to see if it works. So I'm going to start this, and if you guys could answer those questions, we'll see if it works. Are you guys all able to see the polls? Hold on, I can't see the chat. There we go. Cool. Looks like it's working. Nice. So I'll just let that keep going for now while you guys are answering that, I guess. So I wanted to mention Slack. It looks like probably all of you guys are in Slack since you guys got the Zoom link, which is good. I would highly recommend that you guys download the app onto your computers and also onto your phones and then set up notifications for it, because I'll be posting stuff pretty frequently in there, and I'll do probably all of the course communication through Slack and not with email if I can avoid it, just because it's easier and it keeps it all in one place so everybody can reference it whenever they need to. So I'll post these slides again in the Zoom recording channel after this class, just so you guys can click on the links that are in here and get the apps if you want them. I wanted to talk a little bit about how Slack is structured here. So these are the channels that I have set up for the class. We have the announcements channel, which I'm the only one allowed to post in there. And I'll be posting here frequently, probably every week, telling you guys about upcoming deadlines for things, if due dates change, just because things do change throughout the quarter. You can respond to stuff I post in there by making a thread off of that. So if you have any questions, feel free to do that. There's also the lab discussions channel, which is where you guys are free to post whatever questions you guys have about anything related to the lab, including the actual labs themselves, quizzes, review questions, stuff like that. Discuss it all there. You guys can also obviously just use that channel to talk about anything you guys want to relate to the class. The random channel, do whatever you want there as well. It's free and open for you guys to discuss whatever you guys want. And the Zoom recordings channel is where I'll be posting the recordings of the videos, because I know that not everybody is in a place where they can necessarily attend in person for these lab classes. I'll talk about this a little bit more in just a second. But if you have to miss a class for whatever reason, then hopefully there'll be a recording available and you guys can catch up on your own time. And then just a little bit of Slack etiquette here is please try to use threads when you guys are posting in a channel instead of just continually responding to each other in the channel. This makes it so it's easier for other people to come back and review certain topics if they want to. So if everything's grouped under one thread, people can just come back and easily figure out what they need to figure out from that thread. That's just a little aside there. So here's the overview for the quarter. Now this is going to be subject to change, obviously, as things go on. We're still obviously working out the kinks in remote learning for lab classes. And so some of the deadlines here and some of the assignments might shift around a little bit. And that's what I'll be posting in the announcement channel. As soon as I know if there's a deadline that gets moved, I'll tell you guys about it. But this is the general structure for the class. So you can see we have whatever, 10 weeks, 11 weeks. We're going to have 6 different lab reports that will be due throughout the quarter. One thing to pay attention to is that We have 2 different experiments called experiment 15, which is just a bummer, but we had to use an older version of an experiment, this oxidation of alcohol, that was also labeled 15 just because it works better for remote learning than the other one that we had. So the first experiment 15 will be this oxidation of alcohol, and the second one will be the synthesis of alum. And one of these, this oxidation of alcohol, isn't in your hard copy lab manuals. It's only available on Gaucho Space. So just make sure that you're paying attention to which one of those pre-labs you're working on for the given week. So office hours, all of the 1CL TAs will have office hours, and they'll be posted at the same link, the same Zoom link, which is posted on Gaucho Space, and I also posted it in the announcements channel and pinned it. We don't know exactly when our office hours will be yet, but we're going to be deciding that this week when we figure out the best times so that we get a good distribution of TAs throughout the week. So if you guys have any questions about quizzes, review assignments, the lab reports and stuff like that, go to those TA office hours. They're very helpful. But of course, you can always make an appointment. You can message me on Slack. You can post the questions in the lab discussion channel, or you can just DM me and I'll get to it when I can. So lab meeting time. So for this week, obviously we're meeting at the time that's posted on Gold, just because we have to take attendance so that we can make sure that the wait list is handled appropriately. But for future weeks, I'm actually going to send out a doodle poll for both of the sections. And you guys can choose all the times that work the best for you. And then I will pick Friday this week, the 2 best times that have the most number of people that can attend. And I'll host the lectures at those times during the week. I think I'll still stick to Monday and Tuesday just to keep it kind of consistent, but I'll make some options throughout the day just so we can have a better meeting time for everybody. And like I said, I'll post that probably tomorrow night after my Tuesday section meets, just so that everybody has a chance to get to it. And then I'll close it on Friday, and then I'll post the results in the announcements channel. Okay, so for the lab manual, you guys can use whatever you want for your notebook. You can use an e-pen thing, like a digital writing pad if you want. You can use any notebook that you have. If you have your carbonless copy ones from when you took another chem lab at UCSB from before, you're welcome to use that as well. I don't have a preference either way on which one you use. Just make sure that you're keeping it neat and you're uploading it as a PDF consistently every time. We'll talk about that more also as well. So I wanted to go over a couple key points. These are little things that I see in people's notebooks that are just common mistakes that people make. So make sure that you're putting the experiment title, your name, and the date on every page of the lab. This helps keep things organized. Obviously, since everything's digital, you're going to be putting things into a single PDF so things won't get lost, but it's a good habit so that when you are turning in paper copies again, if any page gets misplaced, you have the title, your name, and the date on every single one of those, and that helps everybody stay on track. This is another really common thing that I see people doing. When you're handwriting numbers, or actually when you're typing them too, you should always include leading zeros for decimals. So a lot of people like to just write 0.00125, for instance. But what often happens is you make this decimal point really small, or it doesn't transfer very well in the carbonless copy, and so it gets lost. And this can lead to mistakes down the road in terms of your math and stuff like that. So just always include a leading zero in front of all decimals. And also always use units for every single number that you write in there. If it has a unit, you should write it down with it as well, including in calculations. Whenever you're writing and you make a mistake, don't obliterate it like this. This is something that a lot of people do, is they just completely cross something out or obliterate it. But what you should be doing is just drawing a single line through it. And the reason for this is that, like on the previous page, it said, this is technically a legally binding document that's supposed to be a total archive of everything that you did for a lab. So I know this is just a Gen Chem lab class, but it's developing habits for real laboratory classes or laboratories that you work in. And so you have to, everything you mistake, you just put one line through it so everybody can read it and see what happened. You can just put your initials on it and say, yes, this was a mistake, and then just rewrite it next to it cleanly. When you're writing in your manuals, make sure that you organize and label each section. So, when you have your review questions, make sure you put a little line that says, this is the review question section. When you have your data or observations, also record that. When you're doing calculations for a given part of an experiment, also write something. It doesn't have to be complete sentences or a paragraph or anything, but just make a note of what that calculation is referring to. Because if it's just an equation with some numbers, when I'm grading, I can't tell what it's in reference to. So just keep that in mind. So when you're uploading your assignments, this includes the pre-labs, and it'll include the completed lab reports, which includes everything. make sure that you upload just a single PDF file, because when I download the files from GauchoSpace to grade them, it only downloads the first one that you upload. So if you uploaded like 4 different pages as 4 different PDFs, I'll only get the first one. So make sure that you copy everything into a PDF. So you can use this app here. Adobe Scan is one of the good ones. It's free. You can get it on your phone and you can just convert things into a PDF that way. And then if you get a bunch of PDFs that are all of the same assignment, you can go to a website like this, combinedpdf.com, and you can just merge them all into one document. And then when you upload that, that's what you should be uploading. Whenever you do this, make sure that you check the PDFs after you're done merging them and before you upload, because you want to make sure that something didn't get lost on the way. This happens pretty frequently. Make sure that there's no duplicated pages in there. Make sure there's no missing ones. Make sure that the pages are in the order shown on the rubric for the assignment, or as close as you possibly can get to that. Obviously, there's some things where like a page break will happen across your review questions or something like that. But just make sure you upload it as close as you can to the order that's on the rubric. And also check that all the figures and graphs and things like that are displayed correctly and not cut off, or that the resolution hasn't gotten totally messed up. And a good way to make sure this is working correctly is to copy graphs and tables into like a Word document or a Google Docs thing first, and then save it as a PDF so that it doesn't get cut off. Because if you print directly from Excel to PDF, frequently the page will get cut off in a weird spot. And then check that the typed text for your discussions and stuff and the equations are all displayed correctly. And then make sure all of the pages are the same size. So something that some people do is they'll upload a whole, like a maximum resolution picture of their lab notebook, and it's like 16 megapixels or something like that, and it's just a giant document. And then everything else is a normal size piece of paper, and then there's the picture of the lab manual is gigantic. So just make sure that you put everything into the same size of document. So pre-labs. I know that the syllabus online says that pre-labs are supposed to be done before your lab meeting each week, and that's generally true. I think you guys should do as much as you can to get that pre-lab done before we have our meeting, just because it makes it way easier for you guys to ask questions and participate during class. But the deadline in general will be 10 p.m. Tuesdays to upload to GauchoSpace. For this week, it's Wednesday, just because I know it's the first week and things have been crazy. So make sure that you do the pre-lab for experiment 14 and upload it to GauchoSpace as a PDF before 10 p.m. on Wednesday for this week. And then in this pre-lab, you should also include a technique points section where you take notes from the pre-lab lecture video and the experiment video that are posted on GauchoSpace. And then if this pre-lab is not uploaded before the deadline, so in general, 10 p.m. on Tuesdays, but you include it in your final report, then you'll only receive half credit for it. So just make sure you're doing that and uploading it before the deadline, and you'll get the full 5 points for everything. So lab reports overview here. So each lab report will have these sections in general. I also know that the syllabus says that you don't need to include the pre-lab in your final lab report, but I prefer that you do, because when I'm grading it at the end, it just helps for me to have everything in one place. So take your pre-lab assignment that you already did, hopefully, just put that PDF on the front of everything else using that PDF merger thing. This will include the technique points section in it. It'll include data and calculations. So this could include the Excel tables from each assignment, which are also posted on GauchoSpace, which you should copy into like a Word document. It could also include pages from your lab notebook where you guys have written down calculations by hand, stuff like that. And then it'll include your discussion, which is typed, and then review questions, which are also, you can either type them or you can just handwrite them in your manual. And like I mentioned, when you turn in the final report, it should be approximately in this order, one single PDF document. And the rubrics are posted on GauchoSpace. So when you're writing and when you're working on the lab, I would highly recommend downloading that and just keeping it handy so you can reference it and make sure that you're following all the points. Let's see, hold on, I had a question over here. For the date, should we use the scheduled day of the experiment or when we write the lab reports? That's a good question. You can use whatever, just make it consistent. When you write it, I guess, is the preferred one. Since it's a legal document, it should be the date that you're actually doing the work. Good question. Okay, so as I mentioned already, most of these experiments, since we're doing them remote, they're going to include an Excel file that has basically sample data for you guys. It's usually the data that was recorded when they filmed the experiment video. So whatever they reference in that video, the actual data will be given to you guys in that Excel file. when you need to include them into your lab reports, copy them from the Excel file into a Word document, make sure the formatting is preserved, and then print it as PDF. And usually, so the videos that I do each week for this lab meeting are basically going to be just going over those Excel files and how to do some of the calculations. I'm not going to do too much lecturing about the background for the lab because you guys already have the pre-lab video, you already have the experiment video, so I don't want to go and do too much redundant stuff there. So each lab report will also have a type discussion. I think you guys have all probably taken 1BL already, and so you guys already are familiar with this. Follow the rubrics, make sure you answer the points. If you have any questions about things like that, just make sure that you ask them before the deadline, ask them in office hours. Write them as if you had performed these experiments yourself. So don't say that, oh, Jeff, the TA who did this experiment did this, etc. Like, write it like you did it yourself. And then make sure that you're defining all of the variables that you use in equations, using the appropriate units, and then formatting equations correctly. I had another question over here. Do I prefer questions to be rewritten out or just referring to them as a number? You can just reference the number. That's fine with me. Okay, so for the discussion, this is just some formatting stuff. Include a header for your discussion for every time, and you can single space the header just like this with your name, the section, and then the date, and then a title for it. This just helps me keep track of everything. And then when you're putting equations into your discussion, which you'll have to do a lot this quarter, make use of the equation editor that's in Microsoft Word and also in the Google Docs thing. So in Microsoft Word, you can use the insert equation thing, or wherever you're writing when you can just push Alt and equals, and that'll insert an equation. And in Google Docs is actually the same thing, just insert an equation. And so a good example of equations looks like this down here, where everything is formatted. You've got good superscripts, and same with down here. You have the numbers placed in superscripts and subscripts, and everything is looking nice and not just like this. If you have any questions about how to do that, just let me know and I'll show you how to do it. Okay, something that maybe is different for people if you haven't done, one second, my dog is freaking out. Stop. Okay, you have to upload all of your discussions twice. And the reason for this is that this first upload here, which is just purely your discussion, is checked for, one second, sorry. All right, I'm back. So the discussion uploaded is just a TXT or a doc file is checking for plagiarism against all of the other ones that have been posted for this section. And you have to do this because if you don't upload this, then I can't give you any credit for your discussion that's included as part of your lab report. Just, it's a matter of formality. I know, the number of people who are plagiarizing other people is very, very minimal, but we have to do this just because it's a university requirement. So make sure that you're uploading both times every week. Another question, could you post this PowerPoint? Yes, this will be posted in the Zoom recordings after this is done. Okay, so EliReview. So this is a peer feedback web app. So the way that it works is you guys will all upload a draft of your discussion for this lab to this web app, and then it'll be reviewed by 3 other people from the class. And then you'll take the feedback notes from your peers and you'll revise and re-upload the discussion. Now we're only doing this, as far as I know, for experiment 14, just as a way to get you guys kind of prepared for writing discussions throughout the quarter. And we did this over the summer and we found that it really, really helped people improve their discussions. It does take a little bit more time to do, obviously, because you have to read 3 other people's discussions and answer some feedback questions about them. But we found that this process really helps you guys think about your own discussions and things that you could be missing or things that you could be explaining better. And so we're going to be doing this for experiment 14. And these are the deadlines right now. They're coming up next week. And next week, actually in class, we're going to be spending time just writing the discussions. We're not going to be doing experiment 15 until the week after that. So next week, we'll talk more about this EliReview process and how to do it. Doing these 3 steps for this EliReview assignment is going to count for 3 out of the 8 possible points for your experiment 14 discussion. So it's definitely worth doing this. And then this final full experiment 14 report won't be due for like basically a long time, 3 weeks from now, basically, but we'll talk about that more. We're uploading 2 different discussions. Yeah, so it's the same discussion for each assignment, but yeah, each lab you're uploading the discussion twice. One time just as a plain text document, and then one time included with your full lab report. Does that make sense? Hopefully. Okay, I'm gonna move on to quizzes. So all the quizzes are administered on GachoSpace. These are completely out of my control this quarter. Normal quarters, TAs get to write their own quizzes and grade them and stuff, but because we're doing this remote, Dr. Van Koppen has made all of these quizzes. They're all on GachoSpace, and they should be available every Monday starting at 1 p.m. They're 10 questions and 40 minutes, open book, open note. You should know that they're pretty hard. I think over summer and also in the spring quarter, people generally had trouble with these. And I think one of the main reasons is that people thought that because they were open book and open note, they didn't have to study so much for them. And then they got just bogged down trying to look stuff up in the manual and online while they were taking the quiz. So make sure that you prepare really well for these by, reading review questions and redoing them, looking at pre-labs, all that stuff, reading through the assignment, because once you start the quiz, if you know what you're going to do, then it doesn't take that long. It's pretty straightforward. But if you have to start spending time looking stuff up, it'll take you too long and you'll hit the end of that time limit pretty fast. So just be aware of that. If you guys have any technical difficulties accessing the quiz, like an internet outage or something not working well with GachoSpace, then you should email Dr. Van Koppen and not me, just because I don't have any control over the quizzes, like I said. But if you have questions after the fact, if you get a grade on it and you don't understand why you missed a question, then obviously bring it to office hours or post in Slack, and I'm happy to help you guys try to figure it out. So this is just a summary of the assignments and their due dates throughout the quarter. So pre-labs, like I said, every Tuesday before 10 p.m. generally. Lab reports will be due every Wednesday before 10 p.m. This is usually the week after we do the lab. For this first lab, obviously it's different just because we have the EliReview assignment and stuff like that. But in general, they'll be due every Wednesday before 10 p.m. And that's for both of my sections, and I'll explain that in a second. And then the quizzes will be every week. Do them as soon as possible after our lab meeting, just so the stuff is fresh in your mind. But I think they close permanently Fridays before midnight. So just be aware of those deadlines. Let's see, are the quiz questions multiple choice or free response? I think there's a mixture. There's a test bank of questions for every quiz, and they get randomly ordered for everybody who takes it. Most of them I think are multiple choice. There's a couple ones that are just like short answer, like you type in a number for the answer or something like that. But in general, they're mostly multiple choice. And I also, to these deadlines, I posted a Google Sheet link in the announcements channel. If you guys don't have permission to view this, let me know and I'll fiddle with the permissions, but I'm going to try to keep this Google Sheet updated with deadlines just because things will change, and this should be the source of truth, hopefully, for you guys. Let's see, do we need to type in the procedure of free response questions? I don't know what that means exactly. Can you explain a little bit better? You can use your mic if you want. Move on real quick.
Like, can you hear me?
Yes, I can hear you. Go ahead.
Oh yeah, I'm wondering, like, do we need to type in like how we calculate to the result?
No. So any quiz questions, they won't ask you to explain, as far as I know. It's just going to be like a type in the answer that you get, like the number.
Oh, it's like numeric answer.
As far as I know, I could be wrong about that. I don't know all of the questions, and they might have changed since last quarter. But as far as I know, it's just multiple choice, and then like type in just the number, that kind of stuff.
Oh, okay. Thank you.
Yep. Okay, so these deadlines, you should take them pretty seriously. But obviously, I know it's a crazy time. Things got at hand. Not everybody has time or the access to do these things exactly when they need to be done. So if you need an extension on any of these assignments, the quizzes, lab reports, pre-labs and stuff like that, just message me before it's due. Just tell me that you need a little bit extra time, and I'm happy to grant the extra time, but you have to tell me before it's due, otherwise I can't do anything about it. So that's a standing thing. Just tell me about it before it's due, and I'll do what I can. Okay, so grading. The lab reports, I will grade them pretty much as soon as you guys upload them. So the deadlines, like I said, will be Wednesdays at 10 p.m. So after that deadline, I'll download them all and I'll start grading them as quickly as I possibly can. It usually takes a long time. Grading them on the computer as a PDF with my little e-pen here is quite a bit more time consuming than grading them by hand with a normal pen. So I should be able to get them back to you guys each week before the next one is due, hopefully. If I'm not able to get that back in time, then I'll send a message to the Slack and just say, hey, I'm taking a little bit extra time on these. If you guys have any questions, just message me about them. But in general, I'll try to get them back to you before the next one is due, so you guys have that feedback when you're writing the next one. I'll also be attaching a copy of the rubric to each of your reports, so you don't have to do that yourself. I'll put the rubric in the front, and then I'll give you a breakdown of the final score for each of the sections. And the quizzes are graded automatically on Gaucho Space. I don't have any control over that. I already said that. Any questions about the class structure? You can use your mics or you can type in chat, whatever.
I wanted to ask a little something about the technique points. I was a little bit confused about that.
Sure.
So Dr. Van Koppen in the video said that we had to answer a specific question about finding like the orders. But in like all of the other documents for the class, it said like we had to write down 3 important techniques in the lab. Are we supposed to do both? Or
yeah, so it's an ambiguous kind of thing. Dr. Van Koppen really likes these technique points. I personally don't think they translate well at all to remote labs, because what are we grading you on? You're not doing anything in the lab, right? So for me, when I'm grading these things, as long as you include a technique points section in your pre-lab and just basically write some notes from the videos, that's good enough for me. I'm not going to be grading them to see if they're like good points or anything. Just make sure it's just basically a check for me to see that you guys are watching the videos. So don't stress too much about it. Just write a little bit, write some notes, write some important things from the video, and that's it. And that's fine.
Thank you.
Yeah, no problem. Andrew asks, do we have a final? No, there's no final. The last quiz is a review quiz, and it'll have, I think it'll be 12 points instead of the usual 10. And 2 of those points are from doing just the review questions assignment. So that's the extent of it. Any other questions about the class or grading or anything like that?
So for the lab discussion, and well, like any of the labs in general, how much are you willing to like discuss like in depth about the like answers or like the methods? Because like I have trouble with like every time I take a lab class, I had trouble with like the discussion because I missed something, or like I'm just like terrible at writing. So.
Yeah, so like, do you mean like if you ask me a question, will I answer it directly or will I give you vague answers like most TAs? Is that what you're asking?
Yeah, something like that.
It really depends on the question, right? Like I can't just give you answers, but I'm happy to go over parts of your discussion with you guys to kind of proofread them to tell you whether or not they make sense. I can't rewrite them for you, but I'm happy to read it and say, yes, this is good, or no, you should rewrite it.
Okay, good. It's like I just like want feedback in general, so I appreciate that. Thank you.
Yeah, and you can we can always schedule time one-on-one. Anybody, this goes for anybody. If you want to have a special Zoom meeting and we can talk about your discussions, just let me know and we'll schedule a time on Zoom and we can go over it. Any other questions?
I had a question. You were saying something about changing the lab schedule times. If I heard that correctly, I was just very confused on that. Or like we were gonna I think do a poll or something. Is that what you're saying? At the very start. Can you explain that again?
I'll explain again. So after my class meets tomorrow night, I have 2 sections, one Monday, one Tuesday. So after Tuesday's class tomorrow, I'm going to send a doodle poll to the Slack that will have just a list of times for Monday and Tuesday ranging from like 11 a.m. to 6 p.m. And you guys can pick the times that work best for you. And then once that doodle poll's done, I'll pick the 2 times that have the most number of people that can come to them. And then I'll host the lab classes during those times instead of the usual 5:30 p.m.
Oh, okay. So starting next week, there'll be a different scheduled lab time, correct?
Yes.
Okay, thank you.
And if you're unable to make either of those times, I'm going to be recording at least one of the lectures each week, and then I'll post that to that Zoom recordings channel, and so you can watch it asynchronously if you need to.
Oh, okay. And then do you take off points if we're not here synchronously? Or like,
no, definitely not.
Okay.
Just for this week, just because we have to, there's people on the wait lists and stuff like that, so we have to take attendance. But after this week, I won't be taking any attendance.
Oh, okay, cool.
That said, you should definitely try to attend at least one of the meetings in person, just because in my experience, the people who show up for the lab meetings generally do a lot better on the assignments than people who don't show up. Just something I've noticed.
Yeah, thanks for clarifying.
Yeah, no problem. Any other questions? If not, I'm going to move on to experiment 14.
No.
All right, can you guys see this new one? Okay. Let's see. F5. All right, so we're going to move into experiment 14 here, and this is chemical kinetics. And so I wanted to take a little bit of time here to talk about our goals for the experiment. This is something that I like to do with every experiment, is to take a little bit of time and just kind of summarize in writing what we're trying to do with the lab, just because I know it can be difficult to, like, you have all this information and background material on the lab that just kind of goes into random tangents, it seems like. And so I want to summarize, what are we trying to do with our data in this lab? And we have 3 main goals, and then we also have a secondary goal with this lab. And so our first goal is to quantify the effect of reactant concentration on the reaction rate. And then during this is a sub goal here. We want to prove that the rate constant is in fact a constant for these conditions. Our second goal then is to quantify the effect of temperature on the reaction rate. And then our third goal is to prove that the catalyst that we use for this reaction is not consumed during the reaction, just to prove that it is actually a catalyst and not a participant in the reaction in that way. And then our secondary goal is, so using this data up here, we're actually able to calculate the real concentration of the hydrogen peroxide that we're using. So those are our goals for this experiment. So it's good to keep that in mind when we're going through each of these steps. So reaction of interest here. Hopefully you guys have watched the pre-lab video and watched the experiment video and read the pre-lab. This is the iodine catalyzed decomposition of hydrogen peroxide. And so this is the balanced chemical equation here. Now the rate of this, so we want to quantify our rate, right? And so the rate of this is equal to this rate equation here, this generic rate equation where you have the rate is equal to this reaction rate constant here, times the concentration of our H2O2 raised to some power x, times the concentration of our iodide raised to some power y. And so what this is asking is exactly how much does the rate of the reaction depend on the concentrations of each of these reactants. So that's what this x and y is. And that's what we're trying to solve with this experiment. And something to keep in mind here is that rate is a change in something over time, right? And so in this case, we're looking at the change in concentration of some of these chemical species over time. This can be represented as the negative change in concentration of H2O2 over time, the rate of change of H2O over time, or the rate of change of O2 over time. And so of these things here, which one of these things do you think would be the easiest to measure in a lab? The DH2O2, DH2O, or DO2, and why?
The O2.
Yep, Gerald says gas. So why the O2 versus these other ones? Let's think about it just kind of logically.
Because like you measure for the displacement, correct?
Yeah, so the thing about H2O2 and water is they're both just clear liquids, right? And they're going to be in the same reaction vessel. And so there's no way we can really tell without adding maybe something else how much these things are changing over time. They're just going to be a clear liquid looking like a clear liquid over time. But the nice thing about this reaction is that it makes oxygen gas. And so using the reaction apparatus that we set up, which has the burette and the seal and stuff like that, we're able to actually measure how much O2 gas is produced over time. And so that's the method we're going to be using to measure all of these quantities. So that's basically what we're talking about here. So the rate, we're going to be measuring the volume of oxygen gas produced versus time. This K value in this equation, we're going to be calculating after we have everything else in the equation. Our concentrations of H2O2 and I- are given in our procedure. And then to solve for X and Y, since these will be 2 unknowns, we need to have multiple different conditions so that we can eliminate some variables and find constants, right? So we're going to compare 2 different solutions where we keep everything constant except for one of those variables. So I wanted to have an aside here because the lab manual does not do a very good job of discussing this here. In class, you guys have probably talked about rates and rate constants and stuff like that. And usually that's reported in concentration versus time, so molarity per second. But in this lab, we're actually doing a little bit of a simplification here where we're looking at volume versus time, or milliliters per second. So I wanted to talk about why we're able to do this in this experiment and why do we do this. And we should also be aware that this is changing our units for K. So we have to be careful when we're reporting these things when we do calculations. So volume versus concentration, why are we able to do this? So this is the general form of how we're going to be solving for our X and Y's in this equation here. And in general, so this is the formula for concentration, right? So if we have this volume divided by a volume here, these things will cancel and we get concentration here. But you'll notice that when we have this equation set up like this, that most of these things will cancel out. So the concentration is going to be staying the same. The concentration of Ki is staying the same. The total volume is staying the same between all these things. And that's why we did this. We did this on purpose so that the volume total is always 30 milliliters and the concentrations of H2O2 and Ki are not actually changing. And so this just basically eliminates everything from there. We're able to just work with the volume since we're not doing different concentrations. Does that make sense to everybody? So this simplifies the equation down here.
Yeah.
That's just something to be aware of. The manual, I don't think, did a very good job of explaining that, but that's why we switch between volume and concentration for this experiment. Okay, so some planning here. So which solution should we make to efficiently measure our unknowns? And we talked about this already. So we want to choose concentrations or volumes of our H2O2 and I- such that when we do this division back here, one of these things cancels out. So we want basically VKI1 and VKI2 to be the same so that that goes away, or VH2O2 and VH2O2 to stay the same so that those go away. And so that's why these different volumes are chosen here. So we can see that for solutions 1 and 2, the only thing changing is the volume of H2O2. And for solutions 2 and 3, the only thing changing is, solutions 1 and 3, the only thing changing is Ki. And so this is our setup for this experiment. And so this is where we look into our Excel sheet and we'll be able to start doing the calculations. So hopefully you guys have all downloaded this Excel calculation table from GachoSpace. I did a little link here so you guys know where to get it. And I think right now my plan is to go in there and actually start doing some of these experiments here, some of the calculations to show you guys what I'm looking for. So I'm going to open that up real quick. Let's see if I can find it. Are you guys able to see the Excel sheet now and not the PowerPoint?
Yes.
Okay. So let's go back here. So this is basically what you guys will get when you download it. Oops, I actually have all the stuff already filled in. Didn't mean to have that already. So you're going to get a table that just looks like this, right? And so keeping with our goal of the experiment, we want to measure the rate of production of O2, right? And so we need to measure the volume of O2 versus time. And so how do we do that from this burette reading? Can anybody tell me what the calculation is or how we relate this burette reading to the volume of O2? Anyone got an idea? So Patrick says the slope, not yet. So the slope will come into play later, but right now, we just want to figure out the volume of O2 first. So how do we fill in this table or this column of the data table here? So the final minus the initial, that'll give us the total volume produced, right? That's good. We want to find the volume of O2 at each step, right? And so you can see here, this first one has kind of been done for you guys. So we can see that, we start at 0 and then we make 2. And so that all that is the difference between these two cells, right? So if you want to use the magic of Excel, we can actually do something here. We can say this is equal to this cell minus this cell. To keep a running total, we want to add, so a plus sign. Whoops. Excel. We want to add this one. So what this will do is say this one minus this one plus whatever the previous was. If we hit enter there, you see that that gives us 4. And if we drag this square down here, it'll fill in all the rest of those. So you can see that over time, remember, this is the procedure in the experiment. We're recording every 2 milliliters on the burette, the time at which that occurred. And so this is the data we're going to be using to calculate the rate. So now the next step, we want to figure out, okay, we want to get the rate of this reaction. So remember, what are the units of rate going to be for this particular equation or for this experiment? What are we trying to measure? Let me go back maybe to the PowerPoint. Let's see. Way back here. So DO2 dt, right? So what are the units of that? I know this is a little bit of calculus, but think of it as maybe delta O2 versus delta T. So what are the units of that? Anyone got an answer? So the rate, remember, is always something per time. What are we measuring the change in per time for this experiment?
Milliliters per second.
Yep, milliliters of O2. So that's what we want. So to get the rate from this, we want to measure this milliliters of O2 versus time, where time is our independent variable, right? So the way that Dr. Van Koppen set this up makes it a little bit hard, because if we just do this, hide this 1 second. If we do insert, and we put in our normal chart here, what we actually get, if we look carefully here, I know that doesn't have any labels, but if we see our y-axis is time and our x-axis is volume, right? And so this will actually give us seconds per milliliter. So that's not what we want. So the best way to do this is to just insert a blank chart like this. It has some random stuff that's already selected, but we want to go up here and select data. We can just remove whatever that is there. We want to pick our data explicitly. So we want to say series X values. So we want X, our time to be X, like that. And we want volume to be our Y, like that. So that's the data that we want. We want to do all of our formatting here. We want our axis titles. We want our chart title. We want a trend line too. Now, something to be aware of is that Dr. Van Koppen says in the video, I think, that you want to be careful to only plot data that's linear. And so which one of these data points here could we maybe exclude from our fit for this case? Anyone got an answer? Which one of the data points along of all of these should we exclude? Yeah, so the first one, right? So this one, if you think about it, is not really a data point for us, right? Because nothing has actually happened at this point yet. And so as soon as we add in all of our reactions together, we put the stopper on, then the reaction starts going. But so it takes a little bit of time for everything to get situated, right? And so this first data point is actually something that we don't really care about. So if we select our data here, you can see over here on the left, we're able to actually just exclude that by doing that. And that makes it so that everything here is lined up better. And then we want to make sure our labels are all put together, volume, O2, milliliters. And then, so to get the rate, someone already said this answer before. So where's the rate in this data here? Remember, we want units of milliliter per second. Slope, right? Exactly. So to get the slope, we need the trend line here. You can right click on it and say format trend line. We want to display the equation. We want to display the R squared value. And so something else that I like to do just to make this look a little bit prettier is these two options here to forecast forward or backward. And if you change the numbers here, you can see that it just changes the endpoints for this trend line and just makes it look a little bit nicer. So I like to do that just to show that it goes all the way through those data points. So from this number here, from this equation, what is our value with units for the rate of reaction for solution 1? Anyone got it? Someone want to tell me the value? What's the slope with units? Anyone? So this is our equation, right? Yep, there you go. Patrick's got it. 0.0272. What are the units? Make this a little bit bigger. Units are in milliliters per second. Perfect. So that's our number that we want to take over to, let's see, where is it? Our calculations. Solution 1, our rate 0.0272. Good. Okay, so we'll now go back to the PowerPoint real quick. Back to where we were. And here we go. God damn it. All right, so here's the graph. Remember to include all of the labels for the axes with the appropriate units. Include a title that is descriptive. So the one that I just did in the Excel was not descriptive enough. It just said solution 1. You should put solution 1 and then include the reaction conditions that are for that solution. And then you want to plot the data, you want to put the trend line, you want to include the equation of the line and the R-squared value for it. Perfect. So we'll do that for all of these different trials, and we'll get all the different rates. So the next step then is, once we have all of that, we want to figure out what X and Y are, right? So I'm just going to give you guys these ones. You obviously have to show the work in your own experiment to show that these numbers actually work out. And the next thing we're going to do is find X and Y. So we want to figure out how much the rate of this reaction depends on this concentration or the volume of H2O2. And so to do that, we pick the two reaction conditions where H2O2 is changing, but the volume of the iodide is not. And so if we go back to our previous tab here, we can see that that's solutions 1 and 2, where our volume is 5 and 10, 10 and 10 here. And if we substitute those values into the equation, then everything cancels out except for the points of interest here. And we end up with this equation here. Solving this for X, like this. And we get X is equal to 0.88. Now, this is just, let's have a little bit of an aside here. So what do we expect this value to be based on our reading from the lab manual and our understanding of this reaction? Does a value of 0.88 make sense? Or what do we think it should be? Anyone have an idea? Yeah, 1, right? So we're expecting that this is a first order reaction with respect to H2O2, but our data don't really show that. And so this is going to be something that we'll talk about when we look at our error analysis more in depth, but it's just something to keep in mind. When you're doing all of the calculations, for instance, to find K, so our rate constant, and everything else, we want to actually use our experimental value. So even though we got a value of 0.88, we don't want to use 1 for the calculations, even though we know that's what it should be. We want to use our experimental value and just follow that through for all the calculations. So we'll do the same thing to find Y. I'm not going to go through that because you guys will be able to figure that on your own. And then once we find both of those things, we want to find our value with K. And like I said, this is really easy to do. We want to do it for all 3 of those trials. Once we know X and Y, then that's the only unknown. So it's just some algebra to figure out what K is. And we want to ask ourselves the question here. So is K the same for each of these solutions within reasonable error? And is this what we expect? And are there conditions where we expect K to change? And so these are questions that you should be asking yourself when you're writing your discussion and while you're processing the data. So that's goal 1 done. We quantified the effect of the reactant concentration. So that in science terms is just we found the X, we found the Y. And then we showed that K is a constant, hopefully, over those conditions. And the next thing we want to do is measure the effective temperature on the reaction rate. So this is part 2. And in order to quantify this, so not just saying, yes, it was faster or no, it wasn't faster, that's qualitative. We want to actually quantify it. So we want to find the factor by which the temperature changed and then the factor by which that changed the rate. So we want to compare these values here with these equations. So you want to say our temperature is equal to this number I times whatever the first temperature was, and then the rate is equal to some number J times whatever the rate was in the first condition. So I'm going to go back to the Excel thing real quick. I can find it. So that is part 2 here. And so we'll notice that this solution is the same as solution 1. So that's going to be the situation that we're comparing it to. So when you're doing that analysis of the factor by which it increases, compare it to solution 1. So this one's 39 degrees C. This one was 18 degrees C. They both have the same volumes for the other ones. So just keep that in mind that you're comparing the 2 same solutions, but at different temperatures. All right. Back to here. Behind this. Okay. So the last thing is we want to prove that the catalyst is not consumed during the reaction. So can someone tell me what method we're going to be using to prove this? Titration. Right. Good. what are we titrating? So we have to think back to maybe Chem1A lab. So our catalyst is what's our catalyst in this equation or in our reaction? May said I, right? It's iodide. And so we titrate it with, you guys are all saying it in chat there, AgNO3. And why do we use AgNO3 for this? Because, yep, silver plus iodine makes silver iodide, which is a solid. But what else do we have to include in this to make sure that we can see the actual endpoint? Because it would be kind of hard just to add AgNO3 because it's making a solid. How would we tell when it stops making a solid, right? Yep, so you guys are answering the question, good. Chromate. So we add a chromate ion in there because once the silver has completely reacted with the iodide, the silver will start to react with the chromate and that'll form a red solid. And so the endpoint will be this kind of muddy red complex, whereas the silver iodide by itself was yellow at first. And so it's kind of a hard endpoint to see. I don't know if the experiment video did a good job of showing it, but that's the gist of it. You just see a kind of a muddy endpoint, and that's when we say that's the end of it. And so let's see, do I have that here? Yep, so this is our equation. Let's go back here, sorry. So this is our equation. I want to go back to the Excel thing real quick, just to show you where that's happening. So that's part 3 here. It's actually part 3, this table here, the titration of solution. So we're basically going to have to figure out how much moles of iodide were in solution when we started. And let's do this calculation together real quick, just so everybody's on the same page. So where are we getting this value from? The initial moles of I- in solution. Can someone do some quick math to tell me what that is? Or just tell me where we're getting it from? Is this something that we need to measure? Or are we using something else to figure out how many moles we started with? Someone's saying 0.5 millimoles. Can you tell me where you got that? Yep, from the volume and the molarity, right? So we're making an assumption here that the volume of this AgNO, or this volume of the Ki that we use, so 5 milliliters of 0.1 molar Ki, we're assuming that both of those values are exactly what they say they are. So this will be equal to 5 milliliters times, there are, what, 1,000 milliliters in 1 liter, times 0.1 moles per liter, equals 0.0005 or 5 millimolar, 0.5 millimolar, right? So that's exactly right. And then the next step is, so we figure out how much AgNO3 we needed to react with that to get to our endpoint. So what is this cell going to be equal to? Anyone got this? It's deceptively simple, some of these calculations. This one is just the final minus the initial, right? This is how much AgNO3 we needed. There, 5.37 milliliters. So then how many moles of Ag plus is that? I'll let you guys, no worries. Feel free to use your mics if you want to, but you don't have to. So then from this, you're able to calculate the moles based on whatever concentration of the AgNO3 that was. So actually this is also some quick maths. Anybody? So what's our concentration of AgNO3 that we're using? So times, divided by 1,000 again, times 0.1 molar again. So there we go. So how many moles of I- were in solution then after the titration? This is maybe a little bit of a trick question. Basically, is this number going to be equal to this cell or this cell? Yeah, so based on our titration here, this is actually how many moles of I we have in solution, right? So let's say this is just equal to this cell. So then our percent recovered, well, this is a little bit different, right? So percent recovered, remember, is just the actual divided by theoretical times 100. So we end up with 107% recovered. Now, in terms of error analysis, let's think about this. Does this number make sense? How could we possibly have 107.4% recovered? Remember the assumptions we were making at the beginning of this part. So basically all I'm asking is this value acceptable or did we make a mistake? Just yes or no. Yes, it is acceptable. And no, so remember, like when we're talking about the error here, we're making an assumption that we used exactly 5 milliliters of Ki, and this was measured with a graduated cylinder, which if you guys remember from Chem 1A, has a certain amount of error associated with it. So if you guys want to do some extra calculations, you can go back and figure out how much error there is in that. And also that it was 0.1 molar Ki, which again, hopefully that's exactly what it was, but who knows, right? So this number here, close to 100%, says, yes, it probably is close enough. Does this mean, for our question though, our question was, is the catalyst consumed by the reaction? Yes or no? Based on our data. Karima says no, 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 exactly, right? So this basically proved, I mean, proved is a strong word, but this is evidence that we did not use the iodide in our reaction, right? We ended up with at least what we started with, so that's good. Okay, let's go back to the PowerPoint. Like this, current slide. All right, so then the last part, this is our secondary goal here, is just to calculate exactly the concentration of the H2O2 that we started with. And so when you buy H2O2 at the store, it says this 3% hydrogen peroxide like this. This usually means by mass. And so what does that value mean? Can someone tell me what 3% by mass means? I know it takes time to type. But when a sample is reported as some percentage by mass. So I'll go to the next slide here. It means that for every 100 grams of the solution or whatever it is, yes, exactly. Gerald says 3 grams of H2O2 in 100 gram samples. What is the remaining 97 grams in H2O2? Mostly DI water. There's probably some other little bits in there. There's probably a little bit of acid and maybe a little bit of base going on in there just because we know that water dissociates itself. There might be trace ions and stuff, but 3% by mass just means in a 3 gram or 100 gram sample, 3 grams will be H2O2. And so we can use that to calculate what we expect the concentration to be in terms of molarity. And so I did that calculation here for you guys. So we know that we have, say, in a theoretical 100 gram sample, we have 3 grams of H2O2. Divide that by the molar mass of H2O2. We're going to divide that by the density here, which is grams per mil. Sorry, I forgot to put the gram on that one. Now, this assumption here is that it's the same as water, and this is a pretty good assumption just because 3% H2O2 is basically just water. If you get more concentrated hydrogen peroxide, it actually gets higher density, but because this is so close to water, we're able to just say that it's the same density as water, and then doing the conversion between milliliters and liters, and we end up with 0.88 molar H2O2 with a couple extra sig figs here, just because all of these numbers are basically exact. But when you report this, you should just report it as if you were able to measure it. So 0.88 molar is fine. So then we want to compare this value. So this is what we expect the concentration to be. We want to figure out from our experiment then what our actual concentration was. And so how are we going to do that? So we need to figure out the total number of moles of H2O2 that we started with in a solution, and then divide that by the total volume of H2O2 that we added. And so this is not quite as simple as it seems. It's got a couple extra steps to the calculation here. So how can we do this? So let's remember that any liquid at a given temperature has a vapor pressure. And this is called Dalton's law. Some of the molecules that are in a liquid will have enough kinetic energy to escape the liquid, and so they contribute to the total pressure that is in the container. So when we're measuring, for instance, go here, when we're measuring the amount of oxygen produced, we need to be aware of something else. So this is being collected. Yes, these slides are going to be posted also in the Zoom meetings channel. So when we collect the oxygen in the burette, right, what's something that we need to be aware of in that situation? Is it just oxygen gas in there? And if not, what else is in there? Right. So if we go back here, we have a situation like this over here, the orange and blue, where we have, say the blue is the water vapor from the burette, and the orange is the oxygen that we've made. So our total pressure in there is actually the combination of both of those things. And so in order to measure the number of moles of O2 that we made, we actually need to subtract the water from that. And so that's a little bit of an extra step here. So in order to get our moles of O2 here, so this is our calculation we want to end up doing. We want to find the moles of H2O2 is equal to the moles of O2 divided by 2 because of the balancing of this equation here. And to get the moles of O2, so this NO2 in this ideal gas equation, we need to find the partial pressure of O2 and the volume of O2, right? And so how do we get that? Let me exit out of here. Let's look back at our Excel. So we have these part 3 calculations here where we find all of these values. This is the part that we're doing right now. And actually the data, some of the data that we need is back up here. And so let's think here. So what's our total volume of O2 collected in this burette? So we want to do some quick maths. 33 minus 2.8, Gerald says, and that's right. So remember the volume, any gas expands to fill the volume of the container that it's in, right? And so the total volume is just whatever volume is in the burette. But we need to remember that within that burette is both things. So we have 30.2 milliliters of O2 gas, but then we want to find out how much of that volume is taken up by water. And so we need to get the vapor pressure of the water. And so how do we get that? What does the vapor pressure of water depend on? What's the main variable that we're concerned with? Patrick says temperature, and that's right. And so that's why we recorded this final temperature here. And so in your appendices in the lab manual, I forget which appendix it is, you have to go back and just look up in a table. Thankfully, this is a nice round number here, 39 degrees Celsius. We can look up the vapor pressure there. And so this will be our partial pressure of water that's in there, right? And then our P, remember total, will equal P O2 plus P H2O. And so we want to solve for PO2, we just do P total minus PH2O, go over here, that'll be the pressure here. Ideal gas law, solve for moles of O2, convert that into the moles of H2O2 using the stoichiometry of the equation, divide it by the volume of H2O2 that you added, and there you go. That's the concentration of H2O2, and that'll be, this number here will be equal to this number here, and this is the number that we just calculated in the PowerPoint, 0.88, and so you just compare those two values and see whether or not we're within the ballpark there. So that's the experiment, essentially. That's everything done. So I just wanted to go back and, God, meeting controls. I wanted to spend a little bit of time and do some more analysis of the error here. So this is probably, I'd argue, the most important skill from general chemistry is developing your sense of error analysis. And not just talking about like, you know, we measured the volume wrong, or there was something, some of the product was stuck inside the glassware. Like, yeah, those are valid sources of error, but they're not the real crucial part of like, when you're getting data, you want to say, is this data right, and why or why not? And so you need to spend some time thinking about each step that led through your calculations and how those values could have changed based on different experimental conditions, or what different changes would lead to your observed result. And so the example that I want to use is this, this X value for H2O2. Obviously, you guys should do this kind of thought process for every single value that you calculate, but I just want to spend some time going over this value here. So like we talked about before, we expected this should be 1, but what could have led in our experiment? So with our equation here, this is our calculation, remember, to get X. For all of these different variables, what could have changed, or how could they have been changed to make this value 0.88 versus 1. And so I have made a special different Excel sheet here. Let's see. So I just built this. You don't have to obviously do this for all of your stuff. This is just something I made to visualize kind of how we can think about this. So these values here are our actual experimental values from the experiment. And it just is this equation right here. And then X, just for reference, solving this algebraically, you get this equation over here. And so if we change these values, we can see how this changes the exponent here. So for instance, if we measured our rate for our rate 1, if this was for some reason too low, so let's make this higher, we can see that this is changing our exponent and making it lower. So is that something that maybe could have led to our lower observation there? Anybody want to answer? So let's bring it back to this. So I'll post this as well so you guys can play around with this sheet, and you can just change the values here and you can see how this changes the exponent. And so to answer these questions about like, is this something that probably happened in our experiment, you guys will have to look at the values for these rates. And remember, we got these from looking at the graphs here. So for that rate, 0.0272, are we pretty confident that that's the actual rate, and why or why not? You guys give me a yes or no. Yes, we're confident. No, we're not. Patrick, yes, question mark. So yeah, I would say we are. And that's because this R squared value here is 0.999, right? Now, this isn't necessarily proof positive that this is a perfect result, right? It just means that these data that we collected are linear, right? There could be something else, like we could have had a consistent leak in our apparatus that just made the rate look lower. And that would just mean that all of these data points had the same kind of leak applied to each of them. And so the rate, they're still linear, but the rate was just lower. So that's something to keep in mind, but we know that these data are linear, right? They're about as linear as you could possibly get. And so when you compare for all the different solutions and you want to talk about the error and say, you know, I'm not confident in this rate, use this R squared value to say whether or not you're confident and why or why not. And so let's go back to that calculation here. So something else that could have happened, let's bring this back down to about what it should have been, 5.01, something like that. So if we change the volumes here, so you can see if we were 0.4 milliliters off in our volume for the first solution of H2O2, that could have made our value 1, right? Is that something that is maybe reasonable to assume, is that we were 0.4 milliliters off, and why or why not? Anyone think that that's a reasonable error to make? Let's think about the glassware we used. So if I recall, Jeff was using a 10 milliliter graduated cylinder, right? Yeah, so you can argue whether or not 0.4 is a significant error. I forget the actual tolerance for a 10 milliliter graduated cylinder, but this seems like it could maybe have happened, right? Or at least the combination of, say, this one was 0.2 off and this one was 0.2 off, right? Like all these things, like small errors in these things can change our values over here a little bit, right? So you can see there's an infinite number of possibilities for these things to get us up to 1 over here. And just small changes will give us this 1. So this is what I wanted you guys to think about when doing error analysis, is like, how much change is realistic to expect, and is it within the error for the experiment? And that's a real robust error analysis. So do this for all of them, all of the variables. Like I said, you don't have to go through so much detail to like do this calculation as I set it up like this, but just think about these things. Think about the equations and how the different variables change everything else in the experiment. So let's go back here. So yeah, all these things, right? And I just put these examples here. They're not necessarily, don't take them as the truth source. Like this could be too high, could be too low, all these things, right? Like we just showed, there's infinite number of possibilities for those variables that could lead to a value of 1. And so just keep that in mind. Okay, so that's basically everything I have for experiment 14. As I mentioned, next week, we're just going to be going over the discussions for this, so you guys don't have to do your pre-labs for experiment 15 yet. Make sure that you do the quiz. I think there's a quiz already posted for this experiment that is due by the end of this week. I would work on your drafts for your discussions. I would make sure you do the calculations, do the review questions and stuff like that, and just come next week ready to work on the discussions. But it should probably be a pretty short lab, and it'll just be like a hang out and write discussions and ask questions kind of thing. So that's everything I have for experiment 14 and for this week. Does anybody have any questions?
So for the lab report, when we turn it in next week, do we have to, like, are we just going to be submitting our draft with it? Like,
yeah, so we'll be sending out more links for this EliReview thing, but it's a separate website from Calcs
okay.
Space. So you guys will make an account and then you'll submit your draft there, and then you'll be automatically assigned 3 other people's drafts to review. But this will happen next week. So.
Okay, so like for this week, we would focus on finishing up the pre-lab and like the lab work.
Yep, do the pre-lab, do all of the calculations for this lab, do the review questions, do the quiz for this experiment, and start working on your drafts. And that's all I do.
Okay, but like we don't have to submit like the discussion part of it,
No,
right?
that won't be for like 2 weeks, basically.
Oh, okay, okay, thank you.
Yep. Any other questions?
No.
Did you say that there was a quiz for this week?
I think there is. Like I said, I'm not in charge at all of the quizzes and when they're scheduled. If you look at the week of October 12th through 18th, there is one quiz posted there. So maybe it's not due until the end of next week. I could be wrong about that.
Oh, okay. Thank you.
Yeah. Anything else?
I can ask you questions about the material through Slack, right?
Yeah, sure.
Yeah, okay, cool. Thank you.
Okay, if no one has any questions, then you guys are free to go. I'll post the recording from this and the slides as soon as I can. Have a good evening.